because you need to be here. You need to be here. All right. So online students, I missed a little bit, and I'll come back and talk about this at the end of the video. So this is your test review. They're going to ask you about what kind of scientific glassware is best for measuring. So just remember, the more little tick marks you have, the better measurement you can get. A big beaker is not going to be as good as like a graduated cylinder. And if I just have this like volumetric flask, it's not going to be that great at all because there's no marks on it. I can put water in it, but I can't really measure a whole lot of stuff. And so just be aware of maybe what kind of glassware you have that's going to work good for you. Maybe go through and study your SI units. I'm going to post on Google Classroom a bunch of these. A bunch of these study sheets for you to be able to look at and study a little bit. These are all in Sapling, and they're always kind of here. I'm not frozen, am I? What's happening? Am I red up there? No. Am I frozen? I am frozen. The pin's bad. Terrible. Aren't y'all loving my wonderful review right now? Yeah. Let's see. Math and science. Probably. So I'll probably post like 5 of these. These are just going to have a bunch of information for you to be able to use. Maybe go over the SI units. Like, what's the SI unit for length? It's going to be meter. What's the SI unit for time? It's going to be second. Usually it's the smallest thing you can have without having one of these designations. So if I got to put like millisecond in or kilosecond, that's not going to be good. You want the smallest unit that's just a base unit. So for time, it's second. For length, it's meter. For temperature, remember, Celsius and Fahrenheit are just made up, so Kelvin's the real one. Let's see what's next. Oh, there's that other math problem where you're multiplying. I got them a little bit confused. Remember the difference between precision. Why is this pen not working? This is a terrible time for this to happen. No. Do you think I got some fancy nice board? I got the old pin board. Dang. Why? Okay, hold on. Let me try this. Real-time IT work. Real-time IT work. Unplug this. Listen for it to go. And I come back in. It's red. Give it a second. Blue. Oh, this is terrible. Oh, now it's all screwed up. What's happening?
Black, blue, white.
Whoa, that's all.
There it is. It worked. It worked. Okay, see? Real IT work. Always, before you call someone or ask for help, unplug it, plug it back in, or turn it off, turn it back on, because it's the first thing they're going to ask you to do. So let's see. I don't need this. What is this? I don't need that. I don't need that. Here we go. Study sheets. What are these? Let me make this bigger so I can read these. Evaluating data, property changes. What was the question I was just about to look at? Oh, precision and accuracy. Property changes. Probably evaluating data. I don't think we got that far down. Was it just math and science? Their precision and accuracy, conversion rates. Significant figures. Yes, up here, precision and accuracy. Know the difference between precision and accuracy. So precision is going to be the level of exactness of your measurement. So basically, if I take a bunch of measurements, how close are they together? Like if I take 10 measurements and they're all very different, that's not very precise. If I take a lot of measurements, close your Chromebook in the back. Hey, take your headphones out and close your Chromebook. Don't make me tell you again, all right? If I take a bunch of measurements and they're all the same, that's good precision. If I take a bunch of measurements and they're all very different, that's bad precision. Accuracy is just how close you are to the actual number. Is it telling you your correct weight on the scale, or is it telling you something very different? Let's see. Know the difference between theory and hypothesis. That's probably going to be definition of science. Come on. Hold on, let me close this out. There we go. Definition of science. Know that a hypothesis is an educated guess. You do have a lot of data to help you make that guess. It's not just a guess. But you have to test your hypothesis a lot over and over and over again before it can become a theory. And theories are generally pretty well accepted. Doesn't mean they can't change ever or that they're absolutely right. But it does mean that we've done a lot of work, and it's probably something that you can trust in at least a little bit. Sorry, let me take this off so you know. All right. Let's see, what else do we have? We have a couple questions about hypothesis and theory. This isn't going to be a long test. I think this one is 25 questions. Maybe 26. 26 questions, so not too bad. And again, I will post probably 3 or 4 of these study sheets on Google Classroom. As soon as I get done making this video, I'm going to post all of the video and the study sheets up here for anybody that wants to use them. So next we're going to talk about property changes. This is going to be extensive and intensive properties, and physical and chemical properties. Come on. So remember that extensive properties change with the quantity. If I get more of something, that extensive property will change, like volume or mass. If I get more, the volume is going to go up or the mass is going to go up. If I get less, the volume is going to go down or the mass is going to go down. Intensive properties don't change depending on how much I have. Like density. If the stick is going to float, the whole tree is going to float. It doesn't matter how much wood I have, the density is going to be the same. Or the temperature, or the melting point, whatever that happens to be. Physical versus chemical properties. Physical properties, I can check that property, and when I'm done, I still have the same thing. Like I can check the color of a diamond or how hard it is, and that's not going to change the fact that it's a diamond. Chemical properties, the only way I can check that is by actually doing a chemical reaction, and now I've changed it in some way. So like the doorknob rusting, is this metal going to rust? The only way to know for sure is to let it rust. And then once I've done that, it's already done. There's no going back from it. So that's the difference between physical and chemical, extensive and intensive properties. There's some questions about that. There's questions about chemical changes. So remember that a physical change in general, you can go back from. A physical change is usually going to be a phase transition, solid liquid to gas, or me like physically tearing a piece of paper, which technically you can't, like, I guess you could tape it back, but that's still just a physical change. You still have the 2 pieces of paper that are essentially exactly the same as when you started. Chemical changes require a chemical reaction, and generally you don't go back from that. You've created a brand new substance that did not exist before, and so that's going to be a chemical change that's difficult to go back from. Like wood burning, there was no smoke, there was no ash before I burned the wood. Now that it's burnt, I can't take the smoke and ash and like put it back together and make more wood out of it. That's not going to happen. Food rotting, food cooking, all of these things, metal rusting, those are going to be examples of chemical changes. Let's see what else. There's some questions about that. Then I think, I'm to the bottom of this. I keep saying they, but it's me. I have the questions. We're going to get into states of matter and classifying matter. So for states of matter, if this opens up, come on. There we go. Know the difference between solid, liquid, and gas. Know that solids, your molecules are packed tightly together. They don't move past each other. This molecule up here in the top right corner is always going to stay there in the top right corner. For temperature, there's a little bit of vibration, but they're not really moving. For liquids, they're packed tightly together. They're all in the bottom of the container or wherever your liquid happens to be, but they're moving. They're always moving around. Liquids are always shifting. For gas, they're always moving. This is the fastest moving particles, but they're spaced out. They're really spaced far apart, which is what makes it a gas. And why, in general, unless it's a colored gas and you got the right lighting, you can't see gas. We breathe in air all the time. You can't see any of the air that's always around you. So those are your solids, liquids, and gases. There's only one page for that one. Nice. And then let me close that out too. Lastly, the last thing we talked about this 6 weeks was classifying matter. And these might be some of the tougher questions because we haven't been going over this a whole bunch. We just got the assignments done. And y'all did have a lot of questions on these assignments, not just this class, but every period. People at home, if you have questions, email me. Sometimes I answer a lot of questions in class for students, and I don't get no emails from the people at home. So send me an email if you got questions. Know that a pure substance basically has a defined chemical composition, and it means that everything is the same. All of your atoms in that pure substance are the same. They might be just one element, like chlorine. If I have chlorine gas, it's all chlorine. And so that's both an element and a pure substance. Or it could be a compound, like H2O is a compound. It's made up of two elements, hydrogen and oxygen. But if I just have water, if it's pure water, a pure substance, the only thing in that beaker is going to be H2O molecules and nothing else. So a pure substance can be an element or a compound. An element is just one element. A compound is multiple elements put together in a molecule. The other side of that is going to be mixtures. A mixture is going to be something that we just physically put together. It's not going to be a chemical reaction. You're not going to have any molecules bonding. There is no formula for a mixture, not like a chemical formula. So you have two different types of mixtures. Heterogeneous, which hetero means different. So I can see the different things in here, like oil and water, like trail mix, like nuts and bolts mixed together in a bag. Or homogeneous, where it all looks the same, but each different thing retains its properties. So like salt water. The water's still water. The salt's dissolved in there and you can't see the salt, but when you taste it, it's still salt. It tastes like salt. It acts like salt. I can evaporate all the water away and there will be salt left behind. So they're technically separate in the mixture, but you can't see them, so they look the same. They're homogeneous. Same thing with like sugar water or air. Air is a mixture. It has nitrogen, it has oxygen, it has carbon dioxide, it has water vapor. All of those things are separate. They're not one chemical. They're all floating around here separately, but you can't see any of the differences between them. It's all just air to us, and we breathe it all in just the same. So that's your heterogeneous and your homogeneous mixture. And I think that's the last page. Nope, one more page. Oh, this is just a flow chart to try to help you figure it out. Does it look the same or does it not look the same? If it doesn't look the same, it's a heterogeneous mixture. Done. If it does look the same, you got to try to figure out, is it just one single element? Is it a chemical compound like water or sugar or something like that that has its own molecule? Or is it just a mixture where everything kind of retains its individual properties, but you could separate them out like salt water or sugar water or something like that? So I think I've kind of gone over everything, I hope. Some of these questions I did get off of, oh, that's not good. I'll have to fix that. Some of these questions I did get off of, what's it called? Aware. So you may not have seen them before. Most of the questions on here, I think there's 26 questions, so probably 20 of them I took right off of sapling assignments. So you literally have seen these before, and hopefully have seen the right answer, because even when you get it wrong, sapling shows you what the right answer is. So I will post this video. I will post the study sheets, and you can go back and go through your sapling assignments. The quizzes should be even more helpful than just looking at the regular assignments, because I only use multiple choice questions, so they probably came out of one of the quizzes. So you can study with the quizzes too. If you have any questions, let me know. Shoot me an email if we're already out of class. That goes for you too, online people. And y'all can go ahead and find something quietly to do. I'm going to go through that math problem that I didn't get earlier for the online people, and then I will end the video. So, starting back over for the online people, there's a couple math problems at the beginning. Let me move this so you don't have the reflection in there. Nice. Couple math problems right there at the beginning. You're going to convert into and out of numbers in scientific notation. So just make sure you know how to move the decimal and put an exponent after your times 10 to put that number in scientific notation. Remember that you only want one number in front of the decimal place, so like 1.24, not like 12.4 or anything like that. And the number of times you move the decimal gives you your exponent. If your number was small beforehand, you're going to have a negative exponent. If your number was big before, you're going to have a positive exponent. And then the only other thing we're going to be doing is a couple math problems where you will do some addition or subtraction or multiplication or division of numbers in scientific notation. So, maybe I shouldn't have done that. So first thing, we're adding here. You will have a scientific calculator available to you on the test. If you use brackets around the numbers and then have a plus sign in between, it should do everything correctly. You should be able to get to the correct answer pretty easily. But I do want to show you how we're going to do this on paper if you like to do the math. People who like to do the math are cool. I actually watched a YouTube video about a really crazy math problem yesterday. I don't know why I did it, but it was actually interesting. It's just a YouTube video about math. Sounds like punishment, but it was pretty cool. So what you want to do to add numbers in scientific notation, the exponent has to be the same. And the reason the exponent has to be the same is because the problem will actually look like this. So if I move the decimal 3 times and put this into a normal number, it's 6,450. But down here, I only move the decimal twice. So this number is actually going to be 721. So if you're adding these numbers, you can't add them straight down just like they are. What you need to do to add or subtract numbers in scientific notation is make the exponent the same. And in order to do that, I need to move the decimal. So if I move the decimal 5 times to the right, my exponent over here is 5. And so if I need to make my my exponent bigger from a 2 to a 3, I need to move the decimal 1 time to the right. So now my number becomes 0.721. What I do with this exponent in the times 10 is I keep it there. The answer is times 10 to the 3rd power. And then I can just add these numbers, which would be 13.66. Nice. 13.66 times 10 to the 3rd power, which is not actually a correct answer for scientific notation. I would have to move the decimal 1 more time and make it 1.366 times 10 to the 4th power. And so to show you why it works out like this, let's do the normal problem. Wait, no, I did it wrong. Maybe I'll edit that part out, or maybe I won't. So I got to remember here, I moved the decimal. So I need to add these numbers like that. It's 6. No, it's going to be 7 because I need to carry the 1. 7.171. So I'm adding 6.45 plus 0.721. And so this is actually going to be my answer right here. And to show you why, if I convert them out of scientific notation and just add them as regular numbers, I'm going to get 1, 7. This is going to be 11, carry the 1, 7, 171. And then if I move the decimal 1, 2, 3 times here, I will get 7.171 times 10 to the third power. There we go. That makes better sense. So sorry, I made a little mistake. But if you use the brackets, you should be able to put it directly into your calculator. There will be a calculator available to you on the testing software, which will be Aware. And I will send out an email about how to log in and be able to take the test in Aware. Let's see. Anything else? There will be a multiplication problem. Let's just go ahead and do a multiplication problem for this. Let's say we have 8.21 times 10 to the 12 times 6.45 times 10 to the third power. If you're multiplying, you're going to multiply these numbers like normal. You just need to add the exponents. So I'm going to have times 10 to the 15th power, 12 plus 3. And then I'm going to multiply these numbers like normal. I don't want to do this in my head, so let me do it on my calculator. Because I'm being lazy. 8.21 times 6.45 is going to be 52.9545. But if I have the number 52 in front of my decimal, that's not okay for scientific notation. So I'm going to need to move this once and get 5.29545 times 10 to the 16th power. Now, if you have a calculator, just put brackets here. Hit the times button, put brackets there, and multiply these two numbers inside their brackets. Multiply them together, and you should be able to get this answer straight away in your calculator. So I hope this helps you out a little bit and gets you prepared for the test. I will post this video into Google Classroom along with these study sheets that you saw. They should help you out with studying. Go into Sapling and look at some of your quizzes, look at some of your homeworks, and you should be able to feel pretty prepared for the test, hopefully. It'll be 26 questions. We'll take it tomorrow. So if you have any questions or you need any help, please just let me know, and have a nice day.